Section 5.2.1 is about the inverse of an exponential. So problem 5-54, an ancient puzzle. Part A through F below are similar to a puzzle that is more than 2,100 years old. Mathematicians first created the puzzle in ancient India in the 2nd century BCE. More recently, about 700 years ago, Muslim mathematicians created the first tables allowing them to locate the answers of this type of puzzle quickly. Tables similar to them appeared in school math books until recently. Here are some clues to help you figure out how the puzzle works. So, when we see that first one, we say log base 2 of 8 equals 3. So apparently that's a fact. Log base 5 of 25 equals 2. Log base 3 of 27 equals 3, and log base 10 of 10,000 equals 4. So we want to use these facts to try to figure out the answers use the clues to determine the missing pieces of the puzzles below. So we are trying to figure out, how do these numbers relate to each other? 2, 8, and 3, the way it's written. Can you think of any way to use those numbers to write a mathematical statement that's true? Well, hopefully you've been studying your exponents, and you should know that 2 cubed equals 8. So apparently, log base 2 of 8 equals 3. Let's see if that works for the other one. 5 squared equals 25. That is true. 3 cubed equals 27. That is also true. So I'm kind of doing this thing here. 10 to the 4th. The exponent tells us how many zeros there are. So that is also true. So now that we've rewritten them, we should be able to figure out the answers to the pieces below. So notice I'm going to do it on the log base 2 of 8 one. If I circle that, 2 cubed makes 8. So maybe we can do that down here. 2 to what power equals 16? 2 times 2, how many times? 4 times. Maybe I should change the color. The answer to that one is 4. Okay, let's keep that same idea going. Circle that one raised to that power. 5 cubed equals, this time the x is over here. X is going to be 5 times 5 is 25 times 5 again, 125. See if you can do some of the others. 2 raised to what power equals 32. What raised to the 4th power equals 81. What raised to the 2nd power equals 100. 100 raised to what power equals 10. Pause your video and see how many of these you can answer on your own. So 2 times itself, remember it's not 16, that's not the answer. It's 2 times itself how many times? 2 to the 5th power equals 32. What times itself 4 times makes 81? 3 times 3 is 9, times 3 again is 27, times 3 again is 81. What squared makes 100? 10. 100 to what power makes 10? So this is why we reviewed our exponents. I actually want to take the square root of 100. So in order to take a square root, that power needs to be 1/2, because the bottom number is the root and the top number is the exponent, so that takes the square root. So this is how logarithms work, apparently. How is the ancient puzzle related to the inverse function for y equals 3 to the x in problem 5-53? Show how you can use the idea of the ancient puzzle to write an equation in y equals form for the inverse of y equals 3 to the x. Okay, so remember, if it's inverse, we can switch x and y. So they want this equation. That is the inverse of that. But we don't like having y in the air. So if you look back over here, let's do 2 cubed equals 8. That corresponded with log base 2 of 8 equals 3. So we're kind of looking at this over here, and we want to change it to the log form, this form, down here. So if I just match up where everything goes, the 3 is the base, so log base 3. The number that was in the exponent becomes the equal to, and the number that was by itself becomes the big variable. So y equals log base 3 of x is the inverse, because all I did was change the equation's look. I did not change the equation. So that's the inverse to y equals 3 to the x. Okay, that's that lesson.